In this tutorial, we're going to explain how to map an AFM-Raman, which was done using the NWS software and the wire of Rainishaw. So first we did a certain AFM scan in the NWS software. We got a certain image. We save it in files as a NAN file. Okay, so it might be that it was already auto-saved. You can also save it in a certain location. So we're going to save it in a certain location. Okay, in this case it's already saved here. And now we want to also save the different acquisitions which were taken in the wire software. So we have here this one window, but inside it has all the different measurements. You can cycle through them and see the different measurements. You want to save them as a multi-data set save. We do export all. We save it as a text file. We save it in a certain location, and we save it, okay, inside a certain specified file. Okay, let's now, after we saved it, I'm just going to close wire just to save memory, so everything will run a little bit quicker. Okay, so we saved the NAN file and we saved all the wire different acquisitions. Now we want to map them together. So we're going to use the SpectroView. Okay, so first we're going to import the AFM. Okay, this is importing the NAN file. Okay, so we're going to choose the NAN file, and here it is. We can look at different channels. Now we're looking at the height channel. You can look at the phase channel, for example. We can change the color if you wish. Okay, look at different color. Let's go back to the green. We can do some simple basic image processing. Okay, AFM, let's say remove line bias. You can always reset it back to what it was before. And now we're going to import the spectra from Rainishaw. Okay, so we have to choose this file where we saved all the acquisitions. We open it, and then we choose current folder. Okay, now if we have more than 200 spectra points, it's working in low memory mode. It just means that you shouldn't erase any spectra files. That's all. Okay, so it's now creating the map. Okay, so here is the map of the different acquisitions. We can look at different points. Okay, this is now the cursor. Now here is 1, 9. Okay, 116, different points, and down here on the lower scope, we can see how the spectra looks at different points. Okay, and to create this map, so in this case now it's doing an intensity integral from 383 to 644. You can of course change it, or you can look at different spectrums and you'll get a different map. For example, if we do here, we're not going to see something special because we're looking at silicon, which is around 523, but just to show the principle. Okay, so we got a different map, but we really want to look what happens at this area. Okay, we can also look at the wavelength of maximum intensity inside this bandwidth between two of these cursors, but we're going to keep for now the intensity integral. Also here you can do some different options by right-clicking on the map. Okay, you have different options. You can also change the map color. You can also save this as an image. Okay, export data save graph image. Okay, we'll also save it in a certain location. We'll call it silicon grid. Okay, if we open it, okay, this is how it looks like. Okay, it's a regular image. Can't do any processing here. Okay, and also for the map of the Raman, we can also do some simple image processing in Edit, Map, remove line bias. And there's more options which all can be seen here inside the manual. Now, let's save it in such a way that we can open it in WSXM. So we're going to File, Save Map. Okay, we'll call it Silicon Grid. Okay, we're going to save it as a DAT file. Okay, so now we're more or less done with the SpectroView, and now let's open the WSXM. Let's just show how we open it from the beginning. So first we're going to open it as a heuristic open. Okay, we're going to open the location. So this is what we saved. It adds to it the name map XYZ. This was the DAT file which we just saved. Okay, we have to choose here ASCII, XYZ, and also we're going to change here the units. Okay, it's not nanometer, it's really counts. So we'll choose number, and you can press here preview, and here it is, and we load it. Now let's open the AFM also here in WSXM. So that's the regular way, as we always know in regular scanning AFM. So what we do is we save it as an STP file. We're going to save the height trace and do save. Call it also Silicon Grid. And here we open it in the regular way. Here it is. And here we go. Now, here's an important thing to note. If we look here at the NWS, okay, so let's look here how it's mapped, and let's look here how it's mapped. Okay, you see that it is inverted. Okay, when WSXM opens the STP file which is saved in NWS, it inverts it in a mirror image in the vertical direction. So what we have to do is we press here, and there we go. Okay, let's close this. And now so we see that the overlay also makes sense. Now we want to create a map, an overlay map in WSXM. So how do we do that? So mostly we do that using the 3D image. So if we have to press on this window here. Okay, just to choose it, not this, but this one of the AFM. We go to 3D. Now mostly what we do is we go to texture and we do change. But what will happen if I do change? There's no other texture to change. Now, why is that? Let's look at the info of this image. We have here the info. It's 256 by 256 points. But here the info of the Raman is 17 by 17 points, because that was all the acquisitions which we took. We don't take acquisitions at every pixel. So in order to overlay this image on the AFM image, we have to change the pixels here. So the way we do that is we press here, and we're going to change this to 256 by 256, and press OK. And now again we're going to press on the heights, go to 3D. Now we can go to texture, and now we're going to choose the DAT file here of the Raman, and now it's overlaid on it. It's a little bit hard to see, but the color is the Raman, and this background topography, that's the height, that's topography. We can add just a couple of features. We can change a little bit the Z scale. Now, to see the color better, so let's choose here color. Let's choose spectrum. Okay, just to see that it's similar. We can also do that here. Okay, so we have here an overlay of the spectrum here on the AFM image. You can also, if you want, press here and play with it a little bit. You can play with tilt. You can also play with the lighting on it, just to see maybe the color is a little bit better. There we go. Yeah, and also, for example, sometimes what people want to see is to see this. So what you do is just copy it to clipboard, and then you can just see that it's on the clipboard. That's it for now.